Hi there and welcome to the first calculation video for topic 1 and for this course. Now, I'm aware that the title of the video is the empirical formula, but there is something that we actually need to look at before we can do calculations surrounding the empirical formula. And this is something called the relative formula mass. And the relative formula mass is calculated by adding up the relative atomic masses of the elements in a chemical formula. So we work out the relative formula mass not for individual elements, but for compounds like lithium chloride. And I think this is best explained by going through a couple of examples. That is exactly what we're going to do. We'll start with lithium chloride, and all we need to do is add up the relative atomic masses of the elements. Lithium, if we round it up, has a relative atomic mass of 7, and chlorine has a relative atomic mass of 35.5. If we add these two numbers together, we get a relative formula mass of 42.5 for lithium chloride. And that's quite a simple example. We've only got two elements in this formula. A bit more of a difficult example is aluminium sulfate, something like this, which has this chemical formula, and it might make you feel a bit ill. But I promise you, it really isn't too difficult. If you break this down into steps, you can get the relative formula mass of something like this. So if we look at the formula, we have two aluminium atoms in this formula. And we have three of these sulfate ions, indicated by the number 3 next to the bracket. So however many of each element is in this bracket, we multiply that by 3. So we have one sulfur in this bracket, we have 3 sulfate ions, so we actually have 3 sulfurs in total. We have 4 oxygens, but we have 3 brackets, so 4 times 3 is 12. We have 12 oxygens. So now what we do is look at the relative atomic masses of these elements. The relative atomic mass of aluminium is 27. We have 2 aluminiums, that's 2 times 27, which is 54. The relative atomic mass of sulfur is 32. We have 3 of them. 3 times 32 is 96. The relative atomic mass of oxygen is 16. 12 times 16 comes out to 192. And if we add all of these numbers up, this will give us a relative formula mass of 342 for aluminium sulfate. So quite a big number there. And I threw this example in because it's quite a difficult one, and if you can do this one, then you're fine, to be honest. So now with this knowledge of what the relative formula mass is, we can start to look at the empirical formula and any related calculations, which we will go through in a minute. But the empirical formula is defined as a formula which shows the simplest whole number ratio of atoms in a compound. The molecular formula, if we compare it to that, on the other hand, is a formula which gives us the actual number of atoms of each element within a compound. So this formula here gives us the molecular formula of ethene. This is the formula telling you how many of each element is present in ethene. To work out the empirical formula, what we need to do is simplify the ratio of atoms. We look at the numbers of each atom and divide them all by the number that will fit into each exactly. In other words, the highest common factor. So in this case, this number is 2. There's 2 carbons. Divide 2 by 2, we get 1. We have 4 hydrogens. Divide 4 by 2, we get 2. This is the empirical formula for ethene. We had a ratio here of 2 to 4. All we've done here is simplify that down to a ratio of 1 to 2. That's literally what the empirical formula is. For the other compound, we do the same thing. We look at the ratio, which is we've got 8 carbon atoms, 16 hydrogen atoms, and 2 nitrogen atoms. And we divide by the highest common factor, which is, again, 2. So we divide 8 by 2, we get 4, 16 by 2, 8, and 2 by 2, we get 1. So the empirical formula of this compound is C4 H8N. You won't always be dividing by 2, as we will see in a minute. But just one last point on this. If we look at something like sodium chloride, this formula represents both the molecular and the empirical formula for sodium chloride. They are the same thing. There's a 1-to-1 ratio of atoms here that we can't simplify any further. Water, H2O, is a ratio of 2-to-1. We can't simplify that either. So the molecular formula for water is also the empirical formula. So we're looking at a question now which basically brings together everything we've covered in this video. We're being asked to calculate the molecular formula of a compound which has an empirical formula of CH2O and a relative formula mass of 180. So whatever the molecular formula is, we're given 2 pieces of information about it. The first is that its relative formula mass is 180, and the second piece of information is that we know this formula is going to be in the ratio of 1 carbon, 2 hydrogens, and 1 oxygen. Now, if you want to have a go at this question without me going through some steps on the next page, feel free to do so. This is quite a typical question. It's one which is actually in the specification. You need to be able to work out the relative formula mass, or you need to be able to work out the molecular formula, having been given the empirical formula and the relative formula mass. So there are 3 main steps to doing this question. The first thing we need to do is find the relative formula mass of the empirical formula. The empirical formula is CH2O. We have 1 carbon, 2 hydrogen, and 1 oxygen. If we use a periodic table to get the relative atomic masses, we will, from this calculation, get a relative formula mass of 30 for the empirical formula, that is, so for this formula. So what we do now is divide the actual relative formula mass of the molecular formula, which is 180, by the relative formula mass of the empirical formula, which we've just calculated. So in other words, we're going to divide 180 by 30. This gives us 6. Then what we do is multiply this number by the number of each element in the empirical formula. And this will give us our molecular formula. So I'll write out the empirical formula again, and I'll just show you what I mean. We've got 1 carbon atom in this empirical formula. Times that by 6, we will have 6 carbon atoms, 2 hydrogens, 2 times 6 is 12, 12 hydrogen atoms, and of course 1 oxygen, 1 times 6 is 6. So the molecular formula is C6H12O6, and this is in the ratio of 1 carbon to 2 hydrogens to 1 oxygen. And this is actually called, this is the formula for a compound called glucose. One way you can check if your answer is actually correct is by working out the relative formula mass of the compound based on how many atoms are in this molecular formula that we've got. And if the number matches the number that we're given at the start, then you know this formula is correct.